solve this equation. Once again, we're still looking for what x value works to make the equation, make the two sides equal to one another anytime we're told to solve. But once again, the fact that we have a fraction, the strategy we want to use is multiply by the least common denominator. In this one, deceptively easy, because since these don't have denominators, I can think of a denominator 1. Remember, if you have a fraction with a denominator of 1 or a number without a fraction, remember what that means is I only have one denominator. That x is my LCD. I'm going to multiply everything times x. And once again, think of it as x over 1, right? Because we're only multiplying the numerators. So what we end up with is x squared plus top and top, 6x over bottom bottom, 1 times x is x, equals x times negative 5 is negative 5x. Remember, we multiplied all those. Again, the only denominator we have is unaffected. Everything else got multiplied by x. The whole reason for that, x divided by x cancels out, leaving me x squared plus 6 equals negative 5x. No fractions. Whatever x solves this equation is the same x that's going to solve this equation. Well, let's look at it again. This goes back to our first week when we had a quadratic. If I have an x squared, I can't do a square root because of that x over here. I can't just divide by the negative 5 because I have that x squared. Whenever I have a quadratic, what I've got to do is product property is 0. Get one side to be 0 and factor. X squared plus 5x, put it in order of descending power, equals 0. Now that I have a trinomial, factor it. It's nice and straightforward because I have that x squared, meaning double parentheses, double x's, each a binomial. That gives me my x squared. That means they're the same sign. That means they're both positive. In this case, 2 and 3. Positive 2 times positive 3 is positive 6. Positive 2 plus positive 3 is positive 5. Now remember, when we factor this, fundamentally, what I'd say is x plus 2 equals 0, x plus 3 equals 0. I'd subtract 2 to each side. I'd get x equals negative 2. But remember, our shortcut was change the sign. Changing the sign meant that those are the numbers that solve this equation. But remember what that means is those are the x's that solve this equation. And once again, just go back and show, when I have that fraction, go back up to that original x plus 6 over x equals negative 5. Let's plug in negative 2. If I were to plug in negative 2, I'd have negative 2 plus 6 over negative 2 equals negative 5. 6 over negative 2 is negative 3. Plus a negative 2 is negative 5. That negative 2 checked out. That's one of my answers. When I have that negative 3, check it in completely independently, right? It's as if that negative 2 wasn't even there. Divide, I get a negative 3 plus negative 2. And if they're both negative, I add them together. I get a negative 5. Both of those values work. In Math Excel, separate your answers with a comma, right? And we do not want the parentheses. We still are not talking about ordered pairs. When we have those two individual numbers, that means negative 2 works and negative 3 works. When we solve that equation, we're looking for what works.